Good morning. Analyzing and displaying data students. We are moving on to day 2 of our scatter plot notes. We are going to be working on Google Slides again, so you need to open up this document in Canvas and follow along with me. Pause when you need to switch over and take the notes on your own slide. All right, so our first topic today deals with correlation. So correlation refers to how perfectly or not the points line up from your scatter plot. A strong correlation is when the points line up very closely. A weak correlation is when they don't line up very well. And the way that this is measured is with a correlation constant, R. Here's the formula for R. So there is a formula behind it. You can see that we are not going to actually compute this number. It would take a lot of time and more math than what we know at this point. So I'm just going to delete this, but I just wanted you to know that there is a formula behind this. We are just going to approximate. Okay, so double click in that yellow box there on the left, and these two histograms, or not histograms, but scatter plots below, the dots are lining up perfectly. So this is what we would call a perfect correlation. And when you have a perfect correlation, your R value is 1 or -1. So this is a line that is going in the positive direction. And the way that you read that is you put yourself to the left and you walk to the right. And if you go uphill, then it's positive. The one right below it, it's a perfect line. But since you're going downhill, we would type this in as a -1. Now I'm going to switch all the way over to this one on the far right that appears to have no relationship. So this one we would describe as having no correlation. And that value is 0. So the biggest number that you can get is 1 or -1, right? And the smallest that you can get would be 0. And we're not measuring a slope. All we're doing is trying to assess how closely the lines, the little dots, line up to make a perfect line. Okay, so this guy right here, these ones, they are making an obvious pattern, right? The purple ones are positive and the red ones are negative. So it's a pretty strong correlation. So we would call these guys, or say they have a strong correlation. And this is where you can judge, what's close to 1, but not quite 1. You could say it's a 0.9, a 0.8, whatever. I usually just this one was, from where I got it, was ranked as a 0.9. And this one, since it is going down, and then we have to put the negative in front, but it's pretty close to it's close to perfect, but it's not perfect. Well, maybe it's not super close to perfect. Rank that as a 0.9. And again, it's a bit of a judgment call. Maybe 0.8 would be better. All right. And then these ones do have a correlation, but it's not very strong because the dots are not very well lined up. So that one's called a weak correlation. Well, that box isn't long enough, so I'm going to stretch it a little longer. All right. Okay, so what's halfway between 0 and 1? We would call that a 0.5. All right, and this one would be a -0.5 because this correlation is going down. Okay, so these dots just aren't very lined up, but there is still some correlation. And same with those. All right, we'll go ahead and move on to slide 3. Now we are going to be trying to make the line of best fit. A line of best fit could pass through all the data points, some of the data points, or none of them. When drawing a line of best fit, draw the line as close as possible to all the points with an equal number of data points above and below the line. But we want to ignore the outliers. Okay, so we're going to use a line tool to place the line of best fit. And again, this is not an exact science. So we just have to use our eyes and do our best judgment, the best judgment that we can. So I'm going to go up here and click on the line tool, right where it says line, click on it. And I will, once you get the line on the paper, you can kind of move it around, but I'll just kind of start it here and draw it this way. I'm going to make mine just a little bit heavier. If you want to do the same too, you go up next, up top and hit line weights. I'm just going to make it 3. All right, and then I'm going to click off of it. So we want to just try to make it so that the line, there's just about as many points above the line as below the line. So if I count my points, I'd have 1, 2, 3, 4, 5 above, 1, 2, 3, 4, kind of 5 below. And you don't have to hit any points exactly if you don't want to. If you need to make adjustments to your line, you click on it and then grab the little dot at either end and you can move it around. So I could move it to go through those 2 points. And maybe that red point right there. Now I'm actually going through 3 points and I have 3 points above or 3 points below and 4 above. I kind of like that setup just a little better. Again, it's a judgment call. Okay, let's try to do it on this one. This one's a little harder because the points don't line up. They have a weaker association, I would say, but I'm going to kind of draw it approximately there. I've got, let's see, 1, 2, 3, 4 above and more below. So I need to move my line down. So if you're just going to shift up or down, use your arrow keys. Now I've got 1, 2, 3, 4, 5 above, 1, 2, 3, 4 below. I don't know. I feel like I should go up 1 click. I like that one better. That seems to be a little bit better. Okay, and next line over. So still not a very strong association, but approximately there. I've got 3 above, 1, 2, 3, 4 below. I'm hitting 1 exactly. I mean, maybe I need to bring it down just a little bit. Maybe more like right there. Okay, so we're just trying to judge. Same number of points above as below. And if you can hit some points exactly, sometimes that helps too. We'll go ahead and move on to slide 4. So again, the line of best fit, it could pass through all of the points. It could just pass through some of the points, or your line of best fit could pass through none of them. So we are going to draw another line of best fit, and we are going to ignore the outlier. So there is an outlier here, right? This point down here is an outlier. So I'm going to draw my line of best fit, and I'm not going to really take that outlier into consideration. It's kind of hard to ignore it, though, isn't it? All right, so maybe I'm going to go through those points right there. I forgot to make my line weight heavier. Just, you don't have to. So that now I'll have 1, 2, 3, 4 points above, 1, 2, 3, 3 below, and I'm ignoring the outlier, and I'm kind of hitting 2 points right there. Kind of hitting 2 points. Oops. Use my arrow key. I actually have to select the line to use the arrow key. Okay, I like that. I think that's pretty good. Okay, and we'll do it one more time over here, and we're going to try to ignore the outlier when we do our line of best fit. Okay. So, what have I got? 1, 2, 3, 4 above. 1, 2, 3 below. 3.5 below. I'm going to just move it up just 1 click. No, it's always so hard. I like that way better. Okay. And that's it. And I tried to ignore that outlier down there. I didn't really count that in my measuring of points above and below the line. All right. Solving problems using scatter plots. So When a scatter plot has a strong association, a line of best fit can help you analyze data and make predictions. So if you are predicting within the points you are given, you are going to interpolate. If you are predicting outside the range of the data, then you are going to extrapolate. So those are two new vocabulary words, interpolate and extrapolate. So first we're going to try to create our line of best fit over here on the chart. Okay, we'll go ahead and do that. Sometimes, okay, we'll start there. And I'm going to go through the entire chart. I mean, I'm able to hit, well, these are really big points too. I'm able to hit like 3 of my points, and then I have one kind of above and one below. So I'm just going to leave it about like that. Okay, so how many cups would possibly be sold on a day when the temperature is 89 degrees? Okay, so we're kind of looking on our chart here, and we look for 89 degrees. And it is actually shown on our chart. And when I go up here, wow, it hit 89 perfectly. That like never happens. Or it hit an exact number of cups of lemonade sold. So that is 60. At any rate, we can just by looking at the chart get an answer for that. So when we just look on our line, let's see, that is us interpolating. And if you wanted to actually give the answer, right, we could just read that off the chart, right? 60 cups. Although I don't know if I want to do that because it's going to mess my it's going to mess up the chart. So let's not do that. We won't actually give the answer for it, but we could if we wanted to. Okay, 75 degrees. Okay, so 75 degrees. So we have to make a judgment call. Is 75 degrees outside the range of the data that we are given? Well, it kind of is, right? I mean, it is kind of barely on the chart, I guess. So we could maybe look on the chart. But it is outside of the range of numbers that we are given. So in order to make a prediction, we would have to extrapolate. All right, 64 degrees. 64 degrees is definitely off our chart. Since it's off, that one's completely off our chart and it's not really within the range of the points that we were given, right? Then we're going to extrapolate. 100 degrees is off the chart. So we are going to extrapolate. 90 degrees, though, 90 degrees is within our data range. We can get a value for 90 degrees. My line actually goes right through it. It would be 65 cups. That means we are going to interpolate. And 85 degrees is within our range as well. So we are going to interpolate. I guess the one questionable one was 75. It's barely on the chart. So maybe that's more of an interpolate, but it is not really within the range of the dots that we were given. All right. Slide 6 asks us to, or begins kind of solving problems using scatter plots, which is kind of one of the big things you can do, especially if your scatter plot has a pretty strong association. Okay, so this little box here has just some general questions to go through to analyze your scatter plot. So first thing we kind of look for is it a linear form or nonlinear form? And it looks like we could draw a pretty good straight line through that data. So it's linear. I'm just going to go ahead and delete out nonlinear. All right, so we're kind of answering it's linear. Okay, does it have a positive, negative, or no association? And it's positive. So let's go ahead and delete out everything except positive. Positive, I'll say association. There appears to be an outlier at, let's see, 0 and 80. Let's see, what is the y-axis being counted by? 60, 70, 80. No, but it looks like 5s, maybe 60, 65, 70, 75, 80. So that's 80, 85, 90, 95. So there appears to be an outlier at, and we want to give that location, which would be 0 in the x direction, 95 in the y direction. So we had to name the coordinates of that point right there. Okay, approximate the correlation constant, R. All right. So, I mean, this looks pretty strong to me. So I would give that an approximation of 0.9. And it's positive, right? Because it's a positive sloping line. So I'm going to keep it positive. Okay. And then finally, what we want to try to assess is what is the chart telling us? And that's where we look at the relationship between the x-axis and the y-axis. So this is a chart that's relating hours studied versus the test score that you get. Okay. So to me, the chart is telling me that the more hours that a student studies, the higher their test score is. Oops, let's see. I don't want this to be underlined. More hours a student studies, the higher their score will be. That totally makes sense to me. All right, there's the one random person who did not study at all and got a 95%. Maybe they're just in a class that's too easy for them, and so they didn't really have to study. Okay. All right, we'll do it again. Did I skip a slide? There it is. So now I think we're on slide 6. So, oh, we just did slide 6. Okay. I thought we were going to get to do that one more time, but maybe we don't. All right. So in going over lines of best fits, one thing that we're going to be doing, and I think we're going to do this, I'm going to show it on these notes, and then we'll probably do it again on day 3, but we're going to talk about writing equations for lines. So this goes back to Algebra 1. We'll see what you guys remember from your algebra class. So do you remember how to count a slope? Okay, so what you want to do when you count a slope is pick a point, any point, and count how far you have to go up and over to get to the next point. So I'm going to start here and I'm going to count up 1, 2, 3, 4 over 1, 2, 3, 4, 5. Okay, so there should be text boxes here. We're going to count up 4 over 5. That's the rise over the run. Now, normally in algebra class, we just left it like that. That was the way that we liked it. A lot of times in statistics class, your slope gets put as a decimal. So I just want you to get used to seeing it. So what we would do in our calculator is just hit 4 divided by 5 and see what decimal pops up. This one just gives us a nice 0.8. If it gave us a really long decimal, I think we would just round it, at 1 decimal place or maybe 2. Okay, so now the other way to get a slope is to compute it. So this is the slope formula. M is the variable that always gets used for slope. And y sub 2 minus y sub 1 over x sub 2 minus x sub 1 represent the points that we have to plug into this formula to get our slope back. Okay, so the little points are x sub 1, y sub 1, x sub 2, y sub 2. So to use this formula, we need 2 points. The sub numbers, the ones and twos, don't add any math onto your onto what you're doing. They just are little indicators to show that you have a first point and a second point. All right, we use this formula if we can't easily count from a grid, but we have 2 points. Okay, so we're going to find the slope between points 1, 3, and 6, 7. So these little guys here are to label your points, right? There's the first point, and there's the second point. So we're just going to plug in our numbers into the formula. All right, so y2 minus y1. Right now I have 7 as my y2. And I have 3 as my y1. Okay, and for the next one, I have 6 as my y2 and 1 as my y1. All right, do I have, oh, I don't think I have a fraction set up here, but we can go ahead and just kind of do it without the fraction bar. It'll look like this. We'll have 7 minus 3 is 4, 6 minus 1 is 5. 4 over 5, right? It's the same slope as this one over here because all we did was compute the slope, but without counting it by looking at the coordinates. So look, 1, 3 is that point right there. And 6, 7 is the other point. It's a lot easier to count it off a grid if you have a grid, isn't it? It's just you don't always have a grid. Or sometimes your coordinates are really big and they're just not quite very friendly to just count off the slopes, off the grid. Sometimes it's easier. Let's see, there we go. Oh boy, it turned it into a little tiny fraction. 4/5. All right, and that is 0.8. Okay. Okay, so last thing we'll do is we'll just kind of put it all together and write an equation for the slope of a line. Write an equation for an entire line. Okay, so hopefully y equals mx plus b looks familiar to you. So this is the form that we write equations in. And the m stands for the slope. And the b stands for the y-intercept, as in where does the line cross the y-axis. So when we look at a line, hopefully we can find those two pieces of information. So I look at this line and I see it's a little blurry, but it looks like the y-intercept is right on the y-axis at 1. All right, so I'm going to put a 1 for the y-intercept. The slope is up 2 over 1, up 2 over 1, up 2 over 1. Correct? So we're just doing rise over run, rise over run. How do we go from point to point? So up 2 over 1, which actually just equals 2. You can write it either way. So in order for us to write the equation of the line, we just put those two pieces of information into the equation. So this line would be y equals 2x plus 1. Those little line pieces look kind of funny. I'm going to delete them out. All right, so there it is. Y equals 2x plus 1. That's the equation that represents that line right there. Okay, so a lot of times what you're going to see on a scatter plot is a bunch of dots, and maybe none of them are on the line. So what we're going to try to do when we get to the point where we're making our own lines is mark the stuff that we can. So sometimes it's pretty hard to mark it exactly, but that point went very nicely. So we're going to try to drag a point over to the y-intercept, which was right at 3. And then we're just going to try to find the next exact line, at the next exact point. And this is where, gosh, I mean, it looks like there's one there. That one looks close. I mean, I kind of think this one way down here looks like the most exact point. So it is a bit of a judgment call, and I'm going to stick my point on there. And I'm just lucky that it went on there pretty nicely. Sometimes it doesn't lay on top very well. Okay, so I'm going to try to get my line from those 2 points. So sometimes you have to try to find the points that you're going to use. All right, so our slope is, let's count rise over run. So our rise is going to go down 1, 2, 3, 4, 5, 6, 7. And our run is 1, 2, 3, 4, 5. Okay, so we're going down 7 over 5. That's a slope of -7/5. And our y-intercept is 3, right? That's where the line is crossing the y-axis. So our equation is going to be y equals -7/5 x plus 3. All right, this we're going to have to work on a little bit. Usually people aren't so great at this at the beginning, but after you do a few of them, then it gets easier. Okay, thank you.